Shown in figure are 2 point charges plus q minus q inside the cavity of a spherical cell. The charges are kept near the surface of the cavity on opposite sides of the center. Sigma 1 is surface charge on the inner surface and q1 is net charge on it. Sigma 2 is the surface charge on the outer surface and q2 is net charge on it. Then figure shown in the figure 2 point charges plus q and minus q inside the cavity of a spherical cell. The charges are kept near the surface of the cavity on the opposite sides of the center of the spherical cell. If sigma 1 is the surface charge on the inner surface and q1 net charge on it, sigma 2 surface charge on the outer surface and q2 is net charge on it. Then so here we have a charge plus q and this is a charge minus q. Now first of all we need to understand, due to these two, if you look at in the space around it, then everywhere you will get some value of field. Field will be non-zero because these two are acting like a dipole, and because of the dipole we know in the near point field are non-zero. So everywhere field is non-zero. That means this surface will definitely have a charge density, okay, because these fields will converge, or you can say these fields will terminate on this inner face. So that means the sigma 1 will be non-zero. So it will be like this way. If I show you the kind of a field pattern, the field pattern will be in this manner. You will find the field patterns are like this way. So to receive or to collect these fields, there must be some amount of charges here. So this is positive, so here I will say there will be some amount of negative charge, and similarly for this one, because of negative charge, if you look here, then the field will be towards it, so like this way. So there will be positive charge in it, and yes, field will be there. If you talk about field at any point in the space, so there will be field is non-zero here. Do not get confused that field is zero. Field is non-zero here. Basically the field patterns due to these charges are like this. So charges are there on the inner faces, charges will be there. So sigma 1 is not equals to 0, I can say. But if I draw a Gaussian surface here, this Gaussian surface, so this Gaussian surface, I will say that the flux through this Gaussian surface is how much? Phi through this Gaussian surface is 0. It says that net charge enclosed should be 0. Net charge enclosed must be 0. And why flux is 0? Flux is 0 because electric field within the conductor, we know conductor body electric field is 0. So net charge enclosed must be 0. So when net charge enclosed must be 0, that means the charge distribution will be such that the upper part will acquire negative, lower part will acquire positive. Yes, it will be non-uniform, but the magnitude of charge on the upper part and the lower part will be equal and opposite. So if you calculate the total charge on the inner face, then q1 will be 0 here. So sigma 1 is 0 and we got q1 equals to 0 here. Now let's talk about the outer part. So we know that the conductor was neutral. So finally the conductor has to be neutral because there has not been given any charge to the conductor. So for the conductor to be neutral, inner surface is having 0 charge, so outer surface must also have 0 charges. So I will say that q2 will be also 0 and here sigma 2 will be also 0 because on the outer surface we don't have any charges here. We know that the effect of inner charges on the outer part is 0 in terms of electric field as well as potential also. So here we don't have any external charges, so no charge induction will occur. And due to this configuration, there will not be any charge on the outer surface because conductor is neutral and inner surface of the conductor having zero charges. So if we search for the option that is most the option which is according to our result is option third here. So the correct option should be option third.